The topic of presentation is investigation of curcumin co-crystal eutectic mixture-based formulations for improved bioavailability. The objective behind this work was to address the issue which is pertaining to curcumin, especially its pH-dependent solubility and poor bioavailability. So that issue has been addressed. For that matter, we prepared co-crystals of curcumin using ascorbic acid, and we prepared curcumin vanillic acid eutectic mixture. It has been observed that when we go for curcumin ascorbic acid co-crystal formation and curcumin vanillic acid eutectic mixture formation, there is significant improvement in the solubility of this composite. And ultimately, when we formulate its dosage form, so we find as curcumin solubility has been improved, number one thing. And secondly, as a consequence, we'll find there is enhancement in the bioavailability of curcumin. So basically, co-farmers, what we selected, they are ascorbic acid and vanillic acid. A lot of work has been contributed in our research laboratory, and the method which we adopted for curcumin co-crystal formulation with ascorbic acid was solvent-based, and in case of vanillic acid, simple solid-state grinding method we used. This is what is pictorial presentation of the kind of mixture which we have prepared, curcumin vanillic acid, curcumin co-crystal, and ultimately you could find the bioavailability has been enhanced, and that can be seen in the subsequent slide. See here, in case of the DSC thermogram of curcumin, you will find there is shift in the endothermic transition on the lower side, means the temperature has been, the melting point has been reduced, and ultimately that is an indicator of change in the solid form of the composite. So in case of curcumin ascorbic acid co-crystal, you find that there is relatively appearance of endothermic transition between the melting point of curcumin and ascorbic acid, whereas in case of eutectic mixture, we find this endothermic transition has taken place below the melting point of curcumin. Similarly, you will find X-ray diffractogram is evident, and it speaks about the crystallinity has been retained in both co-crystal as well as eutectic mixture form. And ultimately, you can find in the graph, which is there for solubility, there is significant enhancement in the solubility of curcumin in both curcumin co-crystal along with ascorbic acid and curcumin eutectic mixture with the vanillic acid in both media, that in water as well as in pH 1.2 and pH 6.8. If you see up to what extent the bioavailability has been improved, you can find here almost more than 10 times enhancement in the bioavailability has occurred in case of curcumin ascorbic acid in animal model, and approximately 7 to 8 times enhancement in the bioavailability has been seen in case of curcumin vanillic acid. So basically, if you see this, whatever hypothesis we propose, so that has worked very well. And obviously, curcumin can be formulated in the form of co-crystal as well as eutectic, and later various dosage forms can be formulated. Here we have addressed the issue of pH-dependent solubility, because you know very well curcumin is unstable in the alkaline pH. That issue also has been addressed here. In addition to that, solubility has been improved, and ultimately bioavailability has been improved. So here we have got a great future of taking this curcumin forward, where it can be formulated into dosage form, where stability will be there, solubility is going to be enhanced, and ultimately bioavailability is going to be enhanced, because this is such a wonderful molecule which has got huge potential, and it has got diverse kind of activities, right from anti-inflammatory, then antioxidant, and anti-cancer. Thank you. Thanks a lot.